everyone. My name is Sudhir. I have submitted my PhD thesis in the field of computer science and engineering at BIT University. So this video is to introduce the introduction to the programming languages. This video is only for the beginners, those who want to learn the programming languages for the completely new, those who don't know anything about the programming languages. So you people can watch completely this video. It will be more helpful for you to understand what is programming and how the programming languages evolve and different types of programming languages. So first of all, we'll learn what is a computer first of all. So if you want to write a program, we need a computer at least. So what is a computer? The computer is an electronic machine. It can program it to accept some data and it can process it and it will give you some output, so that it can take from information from the user and it will process some information and it will convert into a useful output to the user. So for example, you are using a calculator, so you are giving the numbers and the operator addition subtraction like that, and it will process into addition subtraction whatever operator you have used, and finally it will give you a output, required output to you after computing the numbers along with the operator. So this is the computer will do. All these are different computer parts. So we can see here RAM is there, processor is there, monitor, CPU, and CD or DVD ROM, cables, VGA cable, and different hard disk is there. So different computer parts are will be there in our system. So next, this is the simple basic computer, what we know very well in our personal life. We will use the personal computers. So this is the basic block diagram of computer. Here we will have an input and output, and in the CPU central processing unit, in this we are having the control unit, arithmetic and logical unit, and memory unit. So we all know in our school days itself this block diagram very well. So now we will see just one lines for the control unit. What is the control unit and what is the arithmetic and logic unit and the memory unit. So let me take some. Yeah. So this is here control unit. So this control unit will not perform any actual processings. So it will manages and coordinates the operations of other components, like whatever inputs you are getting from the user, whatever outputs it is producing to the user, and read and write, and different controls it will manage, and it will send the instructions to the arithmetic and logical unit for the processing. This arithmetic and logical unit will do some the arithmetic and logical operations. That is why the name it is telling like arithmetic and logical units. The logical operations like decision making, arithmetic operations like addition, subtraction, and different processings it will be done by this arithmetic and logical unit in our computer. So the instructions will be transferred to ALU during the processing time. So the control unit, whatever we have discussed in the previous block, this control unit will be transferred some instructions to the ALU during the processing time. And finally the memory unit. This memory unit, the name itself it is suggesting like memory holds or it can store some information. So the data required for processing it will take from the users. So how it is storing means either in a temporary memory or cache memory, RAM memory, or secondary memory. So different memory units will be there. It will store the information, like it can also store the intermediate results. So when you are having a set of different operations, one operation output will be passed to the another operation output. So in that case, the intermediate results will be also stored in some temporary memory location. All these things will be stored in the handled by the memory unit. So this is the brief about what is happening inside the computer. So here you are processing some information like arithmetic and logical operations, and you are storing some information, and you are controlling the different components. So all these things combinedly you are doing to achieve particular task or towards a particular target you are doing. Then we need to write a program. Okay, because if you want to do some ATM operation for withdrawing amount, So there also there will be different logical operations, different arithmetical operations, and there also you need to give some information. There is a need to store some information in intermediate results. Everything will be there. There is a control operations. Everything will be there. So all these things, if you are performing towards particular task, like withdrawing money is your task, so you are doing towards a particular task, then you need to write a program. So we'll see what is a program. First of all, we will use different high performance computers. Like if you want to give a big program, large amount of instructions, use programming is you want to do, so you need some supercomputers. That means they can handle large number of complex operations, not like a simple arithmetic, means like addition subtraction. Instead of that, you can use a huge amount of complex operations. Okay, so now what is the program? Program is the set of instructions. So a program is what? A set of instructions. There will be multiple instructions. So here instruction might be a read instruction or write instruction, or different instructions will be there, or any arithmetic operation instruction will be there. So the program, we can say simply, it is a set of instructions. So multiple instructions you are giving to the computer to perform a particular task, we can say it is a program. But how this computer can understand your instructions? See, for example, in front of me laptop is there. Can I say upload the video into the YouTube? If I say like that, it cannot understand my language. So it should translate my language into the understandable of mission level language, and it has to perform some processing, then it has to do the particular task. So your instructions are not understood by the laptop or any computer. So what we need to do for that, we need to follow some set of operations. We have some set of softwares, specialized programs to convert the instructions into understandable language by the mission. So we can see first of all who can learn the program. Uh, if I want to learn a program, if I want to become a good programmer, should I be a good mathematician, or should I be a good super knowledge in English should I have, or should I expert in the computer knowledge, or should I have good high IQ power, or scientific knowledge should be there for me more, or high qualification is required, like PG, post graduation, or PhD, like that. So these are all questions will arise in every beginner. So my answer is little bit easy. You no need to get a, you no need to have good mathematics knowledge, or no need to have very high IQ powers, but you should have first and foremost thing, you should have an interest to learn new things. Okay, and next, knowledge to access the computer. So you need to write a program, you need to convert into mission understandable format, and you have to do some processing. So you should understand how to access the computer. And next, you should have patience. Why this patience is required? Should the computer will take a lot of time to process your instructions, or your computer will take a lot of time to produce the output? No, but your program will be processed very fast, and it will generate the output even in a fraction of seconds. But the patience is required to debug the errors, because every programmer will get errors. Without error, there is no a good program. You cannot become a good programmer, because every beginners or even experts also will get lot of bugs. There will be different kind of errors will be there. Those things we will see while learning high level programming languages, what kind of errors, how to solve all these things. But at this stage, you should understand that you should have a patience to solve your errors. Okay, and every programmer should have some abstract thinking. This abstract thinking is nothing but like a thinking logical thinking. So if, for example, one practical scenario you want to develop with the program, so you should understand the behind scenario also, not only the physical things what is happening in front of your eyes. You have to understand the behind things, how to write from the scratch to achieve the particular task. Okay, so that kind of idea, that kind of pattern development, all these logical thinkings you should have. So that is what we can also say logical analysis should be there. So next, you should choose a good trainer. So nowadays everybody is following self learning process, because in our social media or in our internet, lot of things are available to learn by ourselves. But a good practice is required and good instructor is required even you are learning from the internet. And understanding the real world perceptions. So every real world perception, every real world problem we can convert into the digital problem. So we can solve, we can automate every real world problem by using the program. Okay, so first of all what we need to do is we have to understand the scenario, we have to understand how to solve this by using the computer program, how to automate the real world things. That is what artificial intelligence and deep learning, machine learning algorithms are evolved. So how the programming language can understand, like what kind of programming language can be understand by the machine? So the machine can understand only binary language, it cannot understand any other. So binary language means what? It can have only either zeros or ones. So it is having a set of zeros and ones. So why this binary language is used to machine means, we know we can understand this a b c, like whatever alphabet, special characters, semicolon, everything we can understand by human. But if you cannot directly give this a to the computer, it cannot understand. So what the developers or computer scientists done when they are designing a computer, so they have given some ASCII characters for each and every high level character. So this ASCII is like American Standard Code Instruction Interchange. So it will convert this high level character to the ASCII code. So this ASCII code you can observe, for capital A it is different and for small a it is different. So in your computer programming, it can easily differentiate between the A, capital A and the small a, and capital B and small b. Each and every character, whatever it is visible in your laptop keyboard, will be given a particular ASCII code. So when you are pressing or something, when you are pressing that key, it is going to convert into ASCII code, and each and every numeric ASCII code can also be converted into corresponding binary code. So this binary code is we can represent like this. So it is a base 2. Binary code will follow the base 2 and 1 bit, 2 bit, 3 bit. Like in decimals, we will have first position, 10, 100, 1000, like that. But here, like 1 bit, 2 bit, 4 bit, 8 bit, like 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, like that. Base 2 power n operations, n number of bits, 2 power n number of bits, it will increase up to that. So for example, if you want to represent a number 1 in the 8 bit, so 0001 is the representation for decimal number 1, decimal number 1. 0001 is the representation for the decimal number 1 in the 8 bit. So this is how we can represent, for example, different. For example, you see here, capital A is having by ASCII code 65, and this is converted in binary like 0 1 000 1. So you can observe here 0 1 5 zeros and 1. So here wherever you got 1, it is the 64 bit, and another first bit you are getting 1. So if you combine this 64 bit plus first bit 65, this is how we can represent a binary language. Okay, so next, there are different types of programming languages. One we have already discussed, that is mission level language. That mission level language is nothing but binary language, that only we can understand, system can understand. And now after that, in if you want to write a huge number of instructions in binary language, it is not possible for the users, because you cannot write. For example, simply take this instruction, add 5 6. So you should understand how to represent A in binary, how to represent D in binary, and how to represent this 5 in binary, how to represent this 6 in binary. So it is very difficult to write large amount of instructions in the binary level language. So what the developers have done is they have developed the assembly level languages. These assembly level languages are nothing but they have given some codes. For example, you want to do the addition, so they have given user can easily understand add is the word which is very much similar to the mathematicians. So add they can use add 5 6. So this is user level, they can give the assembly instruction. So the assembler, this assembler is nothing but a specialized program which is designed by the computer scientists. So they can give the instruction like add 5 6. This will be understand by the user, but system cannot understand. So this instruction will be given as input to the assembler program, and this assembler program will convert into the mission level language. That means it can decode the A into binary, D into binary, and 5 into binary, 6 into binary. So it is having a set of syntaxes and semantics. So it will check based on your instruction, it will convert into the mission level language. This is what assembler language will do. Okay, but still in assembler, if you want to use subtraction, multiplication, so there are different operations will be there. So you should understand the keywords. For example, for addition you are using add keyword, for subtraction you will use sub, for multiplication you will use mul, for division you will use div. So all these things should be remembered by the programmers. Okay, so which is somewhat difficult again. So all the keywords you cannot remember in the real time. So it should be very much uh, very much equal to the usual routine life. So for that, what we are doing, we have developed the high level languages. So here in the same instruction will be written in a more regular scenario, like 5 plus 6. So this is a first class student also can write, he can easily understand 5 plus 6. What is 5 plus 6? So you no need to use any encoded encoded keywords behind for every logical or arithmetic operations. So directly you can use like your mathematics, how you are using 5 plus 6 or 5 into 6, 5 minus 6, like that. So here the high level languages, they are using some compiler or interpreter. We will see what is compiler, what is interpreter. So these are also some special programs to decode your instruction into the mission level language. So they convert your instruction into mission level language. So you need to understand either assembly level language you can use or high level language you can use. But high level languages are more user friendly. You can understand very much easily than the assembly level languages. So we can say these assembly level languages are the middle level languages. Okay, we can say this assembly level language is the middle level languages, because compared to assembly level language, these high level languages are more user friendly. They can easily understand by the beginners. Okay, so that is why we can say the mission level language is more faster than the assembly level language, and the assembly level languages are more faster than the high level languages. Why? More number of conversions will be needed in the high level language, because you need to convert everything into the mission level language. More user friendly things, more user friendly encoded keywords we are using. So you need to understand more syntaxes and semantics in the high level languages. Okay, so there are two types we have seen in the previous slide. There are compiler based high level languages or interpreter based high level languages. What is the difference? Both are converting the program into the mission level language only. Even you are using interpreter or even you are using compiler, both are converting into mission level languages. So what is the difference between compiler and the interpreter? Means the compiler will compile entire program at a time. Entire file it will compile into the convert into the mission level language. But interpreter will convert the program line by line into the mission level language. Each and every line will be converted to mission level language. Next line will be converted after the first line. So like that, line by line conversion will be happen in the interpreter, and entire file will be converted into the mission level language by using the compiler. This is the only difference. And evolution of high level programming languages. So the first we can see Fortran, formula translation. Here it is evolved in the 1953 to 57 for scientific and engineering applications by John Backus. So this is some first programming language. And the list we have used list processing programming language, like high level programming language I'm discussing now. So in 1958 by McCarthy's, for mathematical notations Lisp is used. And next COBOL, communication business oriented languages. So this name itself it is telling like business administration applications we are using. By in 1959 it was designed by the Kodacil. And next ALGOL. So algorithmic languages for developing some algorithms, mathematics and scientific applications. In 1962 it was designed by the Neat Everson. And next ADA. So this ADA programming language is well known by our elders because it has used in 1981 both for the scientific and the business applications. It was developed by the ADA languages. And next basics. So it can also we can say the beginners all purpose symbolic instruction code. The John Kemeny and Thomas Kuch in 1966 it has developed. Next Pascal. In the name of French mathematician, this Pascal programming language is evolved for the mathematical operations. In 1971 it has developed. And in C programming, it is a very well-known programming language, and it became a basic programming language to learn any kind of programming languages, because whatever the C programming containing like control statements or conditional statements, whatever program C programming is used, very much relevant to the in our daily routine language. So whatever we are using the words, same things will be used as a program instructions in the C programming. That is why C programming is very easy for the beginners to learn any kind of programming languages. It was developed in 1972 by Dennis Ritchie for implementing the Unix operating systems. So next C++. It is an extension of C programming in 1980 by John Stostrom. Next Java. It is very powerful programming language because of Java we got lot of advantages in internet and distributed programming languages. All these things are developed even in gaming developed, mobile applications developed. So much revolution it brings into the computer field because of Java. Okay, so still we are many companies are having Java applications. We are having many jobs in software industry based on Java programming language, and it has developed by the James Gosling in 1991 for network oriented applications. So this is some set of high level programming languages in this video, and in next video we'll go for learning a basic programming languages. Thank you.